Alright, let's have a quick look at this. So light rod AD, length 3A. A hits a smooth bore which is perpendicular to the vertical plane containing the rod. Rod carries a load of W at D, so let's put that weight going down. The rod is held in equilibrium by two pegs B and C. They are of equal length. Rod is under peg B and over, so if that's over, so the reaction of that is going to come down, so we'll call that RP, and the reaction of that's going to be here, and that's going to push back the peg, so that's going to be RC. Okay, passes through that theta horizontal. Okay, so let's show that the reaction of that is that. So first of all, let's take a moment at A. Take the moment at A. So what we got perpendicular forces, that's perpendicular to that, so that's going to be at A is going to be A multiplied by RB. That's going the other way, so we'll deal with that later. And this one's going down, but we want it perpendicular, so if I come down here and bring that there, that will be theta, so this will be W cos theta, and times that by 3A, so that will be 3A W cos theta, and that's going to equal 2A times RC. Okay, so we've got the moment there. So what we could do here, just get rid of A's all the way through, so you could say just RB plus 3W cos theta equals 2 RC. Okay, now let's take this one. Let's take let's look at it vertically. So vertically, you got so that's going down along here and down here. Okay, so that's going to be theta is going to be here, and that's going up and along. Theta is going to be there, and we got that as it is. So what we got here, we got vertically coming down, so that's opposite. That's going to be RB cos theta. So we got RB cos theta coming down. The weight is coming down. That's just dropping down like that. Okay, and that's going up, going this way, so that's going to be, that's sine, that's cos, so that's equals RC cos theta. Now if I divide everything by cos, I'm going to get RB plus W over cos theta, which is just going to equal RC. Now if I make RB the subject, so I want it there, RB I can replace with RC minus W over cos theta, that's plus 3W cos theta equals 2 RC. So take RC from there, which gives me 1 RC, and that will be factorize this, so I'll get the W inside the bracket, and I'll get 3 cos theta minus 1 over cos theta. That's going to be the reaction at normal reaction at C. We want to make it look like that form, so put it all over cos, so we get 3 cos squared theta minus 1 all over cos theta, and that's what you got RC. Okay, so we've got that. Now find the normal reaction at B in terms of W and theta. So what we can just do here is, well, we know that RB is equal to RC minus W over cos theta, and we know that RC is that, or even given there, so that's going to be W open bracket 3 cos squared theta minus 1 all over cos theta minus w over cos theta. Now note that if I put the w in there, that will be a minus w over cos theta minus w over cos theta. It's going to be minus 2 w over cos theta. So I can just simply write this as 3 cos squared theta minus 2 all over cos theta and close bracket. Okay, that's the easy way to do that way, that one. Hence, show that theta has that. So, okay, for 3 single figures. So part 2, let's do that here. That was B. So part 2. So we've been told, when is that going to be? Well, we know that the reaction of these are going to be at least, well, they're going to be greater than 0, okay, or equal to or greater than 0. Now, to have theta at its highest value, we need to say that that touches, that will absolutely touch that. So the reaction of that is going to be absolutely 0 on here, okay. So the length of RB is going to be just on the peg to make that the maximum. Otherwise, if there's more reaction there, that will make that angle slightly go in, makes the rod bend a bit in. So therefore, we set to get the highest RB to be 0. Okay. Now, if that's 0, then we've got W bracket 3 cos squared theta minus 2 over cos theta equals W. So that will go to 0, that will go to 0, and we got 3 cos squared theta minus 2 equals 0. So then we get cos squared theta equals 2 over 3. So cos theta equals 2 over 3 square root. Okay, so theta equal cos inverse of 2 over 3 square root. Now that could be plus or minus, but in this case it won't make a difference. So theta, if you do that in the calculator, the cos inverse of root 2 over root 3, you will get 35.264. I'm just going to round that to 3 single figures, and that will be the most theta will be when that is 0, and that will be right against there. Okay, now part 3 is a tricky part. I'll need more space, and what I'll do is I'll do a separate video if you're interested to show part 3. For now, I'm hoping you'll understand this from what I've done. We've got the first 3 parts done, and then I'll do the third part in a separate video. Okay.